Hello everyone, welcome to Programming Knowledge. So I welcome you all to Programming Knowledge. In today's tutorial, we are going to cover adjacency matrix representation. So we are going to represent adjacency matrix in all the representation we are going to cover in this tutorial, whether it is directed, undirected, weighted, or unweighted. So whether it is directed, undirected, weighted, or unweighted, we are going to cover everything in today's tutorial. So let's get started with this. So I can show you two graphs. This is an undirected graph. It doesn't have a weight, and on another side I have a graph which is a directed graph which has a weight. So we are going to represent both these graphs using adjacency matrix, and we are going to see how we can uh, uh, represent them using adjacency matrix and what is the need of adjacency matrix. Actually, when we further proceed with the shortest path algorithms, so there are two types of algorithm. One is I'll cover the shortest path algorithm, so you will get to know where is the need of adjacency list and where is the need of adjacency matrix. So when we cover shortest path algorithm, you will get to know. So both the representations are important, and let's start with this representation. So first, I'll define a print matrix function. So this would help us to identify uh, uh, whether when we implement we'll get to know that our implementation using the print matrix function. So r comma c is equal to len matrix. The number of rows is given by len matrix and column is given by len matrix of 0. Okay, so this is a very standard notation in matrix problems, that row is given by len matrix and columns are given by len of matrix of 0. Now I'll iterate for phi for I in range R, then for j in range C, I'll print matrix of I j end is equal to space, and when we move to another line, for every row we'll print a new line. So this is how we print our matrix. Now I've also defined the test cases. These are the test cases for undirected graph, which is this one, and these are the cases for directed graph with the weight. See that I have a weight also for this one. Okay, so then let's implement this. So uh, v comma e is equal to map map int comma input dot split. Now when I have got the vertices and edges, then I have to generate a matrix of v square. So 0 star v for I in range v. This would generate a matrix of v square. Okay, so this would generate a matrix of v square. Now what I can do, uh, since I have a matrix here, now I have to utilize this matrix. Okay, for I in range e, I'll get u comma v is equal to map. This is a string, so string input dot split. So I have u comma v. Now simply what I have to perform is matrix of u comma. Okay, first, now since I'll get the input as a or b, now you need to observe one thing. I'll show you one thing, that ASCII value of a is 65, but the matrix indices are going to be in 0 1 2 3. So these were going to be indices of matrix. So what we can do, we can subtract the ASCII value of a for every letter. So this would give us 0. Okay, what I mean to say, I'll quickly show you. What I mean to say, like, if a is equal to 65 and we subtract the ASCII value of a from it, then we get 0. Okay, like in the same way, uh, b b v is equal to 66, and we subtract the ASCII value of a, then we get the index as 1. Similarly for C we get 2, and D we get 3. So this is we can generate the indices for matrix, because matrix have indices, so that characters have to need to be converted into indexes. So we can now proceed with this. Now let's move with the part. Now we can do matrix. Now first U is equal to or now this is what I was trying to say, because we need to generate indices, so we would subtract the values from the ASCII value of capital A to get the indices. Now this would give us the indices. Now simply we can do matrix of U comma V is equal to true. So this is how we generate the matrix. Then we would call the print matrix function and would pass the parameter as matrix. So this would be our this case of undirected graph. So let's copy these test cases and run the test cases. I'll have a split window. Yes, uh, since the indentation is not proper, okay, let me do one thing. I'll change this end statement. Okay, let me do one thing. uh, Either I use slash t. Yeah, now this looks pretty fine. Now here you can see I'll compare this graph with this. Or we can do one thing. I'll put this end is equal to instead of true I would put a 1 here. So I think this would be much better. So I'll cross this window and run this program again. Yes. Now here you can see in the graph. Yes, that in the graph here you can see this is our graph, and here you can see that A is connected to, you can here you can see that A is represented like this. Here you can see this is A comma A, then A comma B. Yes, uh, but I did a mistake here. Sorry for the mistake. The matrix of V comma U should also be have been 1 here, because we are using a undirected graph. So I hope I'll quickly give an overview. U comma V has been calculated, and this is matrix of U comma V is equal to 1 and matrix of V comma U is equal to 1. Now I'll run this program. Yes. Now here you can see. Yes. So I'll quickly overview with this. A comma B, this is A comma A comma B is there, as well as B comma A is also there. So A comma C is there, then C comma A is also there. This is A comma A comma B, A comma C, A comma D, A comma E, A comma F is there, then F comma A is also there. So this is how we represent the adjacency matrix of undirected graph. Okay, now in the same way we can do this is how we do it for this is how we do it for undirected graph. I'll comment this out. Now I'll do it for weighted graph. So this would be same for the weighted graph. So here the function would change for I in range E. U comma V comma W is equal to map str input dot split. Now U would be same as we would get the index by subtracting the ASCII value of capital A, and we would get the by subtracting the ASCII value of capital A. So this would return us the indices. Now w should be int w, because this would be, it should be converted to integer. This was undirected, so we did this for both the ways, u comma v and v comma u. But now this would be directed, so we do it for only one process, one part, that is matrix of u comma v is equal to weight. Here now the instead of 1, that this here 1 was a boolean value which represented true or false in case of edge. But now here it will represent weight. This would be the weight. This would be the weight or cost. Okay, cost of edge. Cost in case of edge. Now what we do, I hope this is pretty much fine. Let us copy this test cases for weighted graph, and this is our weighted graph. So we can like now run this program. Then we call our print matrix function in the end. Yes, now here you can see, like I'll show you the graph. This is a comma a, then a comma b is 4. You can see a comma b is 4 here. uh, uh, then b comma d is 10. So you can see b comma a is 0, b comma b is 0, b comma c is 5, but b comma d is 10. So here we represent the weight. Okay, so here we represent the weight, this is weight or cost in case of edge. So this is we implement either the weighted or unweighted, directed, undirected graph using the matrix. It's a very simple implementation. We will look further why we need both these implementations. Thank you guys, thank you so much.